One of the brightest stars in the night sky is hiding a secret that astronomers have spent decades trying to uncover. Betelgeuse, the enormous red supergiant on the shoulder of Orion, has fascinated humanity for thousands of years. It is one of the most recognizable stars in the sky, visible without a telescope and unmistakable because of its reddish-orange glow. But Betelgeuse is far more extreme than it appears. Located roughly 650 light-years from Earth, the star is hundreds of times wider than the Sun and hundreds of thousands of times more luminous. If Betelgeuse replaced our Sun, its outer layers would extend far beyond the orbit of Mars and potentially toward the region of Jupiter, depending on the estimate used for its enormous radius. And Betelgeuse is nearing the end of its stellar life. Eventually, a star this massive is expected to collapse and explode as a core collapse supernova. When that happens, the event could become one of the most spectacular sights humanity has ever witnessed. But the timing remains unknown. That uncertainty became much more interesting when Betelgeuse suddenly changed. Between late 2019 and early 2020, the star experienced an extraordinary dimming event. Its visible brightness dropped dramatically, making it noticeably fainter than usual. Almost immediately, people began asking the obvious question: was Betelgeuse about to explode? Astronomers quickly began studying the star from observatories around the world. The evidence eventually showed that the dimming was not the beginning of a supernova. Instead, Betelgeuse had thrown enormous amounts of material from its surface into space. A gigantic convective eruption sent hot material outward from the star. As that material expanded and cooled, dust formed within it. From Earth, the resulting cloud passed across part of Betelgeuse's visible surface and blocked some of its light. The star itself had not suddenly stopped producing energy. We were simply seeing less of it. The event revealed just how violently a red supergiant can behave. Betelgeuse is not a smooth, quiet sphere. Its surface is dominated by enormous convection cells, with hot plasma rising from deep inside the star, cooling near the surface, and sinking again. Some of these structures can be larger than our entire Sun. And there was another mystery. For decades, astronomers had noticed that Betelgeuse's brightness does not vary randomly. Alongside its well-known pulsation cycle, researchers identified a much longer variation that could not be completely explained by the star's normal pulsations. One possible explanation was a companion. If another star were orbiting Betelgeuse, its gravitational influence could potentially disturb the supergiant's outer atmosphere and affect the material surrounding it. But finding such a companion was incredibly difficult. Betelgeuse is so bright that any smaller object nearby would be overwhelmed by its glare. It was like trying to find a tiny candle next to a gigantic searchlight. For decades, astronomers searched. Nothing could be confirmed. Then observations and theoretical models pointed toward a very specific possibility. If a companion existed, there would be a period when it moved far enough away from Betelgeuse's glare to become easier to detect. Astronomers took advantage of that opportunity. Using high-contrast imaging techniques designed to suppress the overwhelming light of a bright star, researchers were able to search extremely close to Betelgeuse. And a faint source appeared exactly where the models predicted. A companion had finally emerged from the glare. The discovery changed the story surrounding Betelgeuse. The companion, sometimes referred to informally as Betelgeuse B or Beetle Buddy, appears to be more massive than some earlier theoretical estimates suggested. Instead of being roughly Sun-like, observations indicate that it could have a mass several times greater than the Sun. That makes the system much more interesting. This companion is not simply sitting far away from Betelgeuse. Because Betelgeuse has an enormous extended atmosphere, the companion may move through or extremely close to the star's outer layers. That interaction could create a wake of gas behind the companion, much like a boat moving through water. As the companion travels through the supergiant's extended atmosphere, its gravity can disturb the surrounding material and create structures that may eventually become visible through detailed observations. This could help explain one of the long-standing mysteries in Betelgeuse's brightness variations. The companion may influence the distribution of gas and dust around the star, periodically changing how much of Betelgeuse's light reaches Earth. But an even bigger question remains. Could the companion also have played a role in the Great Dimming? Scientists do not have enough evidence to say that it triggered the massive eruption responsible for the 2019 event. But the possibility is fascinating. A companion moving through the outer atmosphere of a red supergiant could disturb enormous amounts of stellar material. Whether that interaction can trigger or amplify the kinds of eruptions Betelgeuse experiences is still an open question. And that means the companion may not just explain something that happened in the past. It could help us understand what happens next. The James Webb Space Telescope adds another extraordinary layer to the story. Webb observes infrared wavelengths that human eyes cannot see. Infrared observations are especially valuable around Betelgeuse because the star is surrounded by enormous quantities of dust and gas. Visible light can be blocked by that material, while infrared wavelengths can reveal structures hidden inside it. Webb can study the temperature of the star's atmosphere, analyze the dust surrounding it, and examine the chemical composition of material that Betelgeuse has expelled into space. Instead of seeing Betelgeuse as a single red point, astronomers can investigate its atmosphere as a dynamic environment filled with rising plasma, cooling gas, dust clouds, and enormous eruptions. Every layer of material surrounding the star contains information about its past. It is almost like reading a historical record written into space. Betelgeuse has been losing material for a very long time. Earlier eruptions created shells and clouds around the star, while more recent events added new structures. By studying those layers, astronomers can reconstruct how the star has changed over thousands of years. This is important because red supergiants are among the most dramatic stages in stellar evolution. Eventually, Betelgeuse is expected to undergo core collapse. When the star finally reaches that stage, its enormous core will collapse in less than a second. The central region will be compressed into an incredibly dense remnant, while a shock wave tears through the star's outer layers. The result will be a supernova. From Earth, Betelgeuse could become dramatically brighter than it is today. It could become visible in daylight and remain visible to the naked eye for an extended period. The event would be extraordinary, but Betelgeuse is far enough away that it is not expected to pose a serious danger to Earth. The exact timing, however, is impossible to predict. Betelgeuse could explode relatively soon on astronomical timescales, or it could remain stable for tens of thousands of years. And there is something even stranger about that uncertainty. We are not actually seeing Betelgeuse as it exists today. The light reaching Earth tonight began its journey roughly 650 years ago. The photons entering our telescopes left the star when humanity was living through a completely different era. The people who looked at Orion centuries ago were seeing Betelgeuse through light that had already traveled hundreds of years. If Betelgeuse's core collapsed today, we would not know immediately. The signal would need hundreds of years to reach us. And if the star actually exploded hundreds of years ago, the supernova could already be traveling toward Earth right now. We simply would not know until the light arrived. That is one of the most humbling realities of astronomy. When we look into space, we are always looking into the past. Betelgeuse has been visible to human eyes for thousands of years. Ancient civilizations saw the same reddish star that we see today. But only recently have we developed instruments powerful enough to examine its atmosphere, detect the material surrounding it, study its eruptions, and investigate the possibility of a hidden companion. For most of human history, Betelgeuse was simply a bright red point in Orion. Now we know it is a gigantic, unstable stellar furnace surrounded by dust, gas, enormous convection cells, violent eruptions, and possibly another star moving through its outer environment. And someday, when its core finally collapses, the star will write the final chapter of its life across our sky. We do not know whether that moment will come during our lifetime, thousands of years from now, or much later. But when it happens, humanity will have a front row seat. A star that has watched over Earth for thousands of years may one day become the brightest stellar event in human history. And perhaps the most remarkable part is this. We are alive during the brief period when our technology is finally powerful enough to watch that ancient giant in unprecedented detail. Betelgeuse has been changing for millions of years. We have only just learned how to see it.